Hello, my name is Erhard Klötzl. I'm coming from Austria, and in this talk I want to give you the answer to the following question. Why did our world develop just like this and not differently? Charles Darwin has already explained much of this, namely how and why the different species have evolved from single-celled organisms to animals and finally to humans. But he was not able to explain everything. Why, for example, did the technologies hearing, speaking, writing, printing, and computer technology develop in this order? Why did the economy evolve from a barter economy to an economy based on the division of labor, and further on to a market economy with money and investment? Why has money evolved from commodity money to coin money, to paper money, and to electronic money? Why could animals imitate and humans learn and teach? Why and when did the different cooperation mechanisms develop? Group cooperation, direct cooperation, debt cooperation, indirect cooperation, cooperation via norms. But more importantly, why has everything been evolving faster and faster? And where is the journey of evolution heading for in the future? Are we heading for a singular point? An answer to this is given by the general evolutionary theory of everything, which explains the evolution from the origin of life to the market economy. In the following, I will present first the general evolutionary theory, we abbreviate GET, as extension of Darwin's theory. Second, the natural chronology of evolution, which follows from the GET, with the parts, the evolution of living being forms, the evolution of evolutionary systems and cooperation mechanisms, the evolution of targeted variation mechanisms, the evolution of debt creation, the evolution of driving forces. Third, the megatrends of evolution. Fourth, the scenarios for the future, and then a selection of further new ideas of the general evolutionary theory. And lastly, I will present my conclusion. The general theory is a comprehensive extension of Darwin's theory. The basic idea is not only to consider, as Darwin did, the evolution from the perspective of genetic information, but instead to consider the evolution from the perspective of general information types and information technologies. It shows that evolution is characterized by the fact that new types of information have developed in leaps and bounds with new storage technologies, new duplication technologies, and new processing technologies. Furthermore, it shows that each new information technology has led to increasingly well-targeted variation mechanisms that have exponentially accelerated evolution. But let us do everything step by step. Let's start with the basic concept of Darwinian theory. A selection system, usually a differential equation system, describes the dynamics of the frequencies of genotypes. A mutation mechanism leads to a new genotype and thus to a new phenotype with a new trait. This leads to a new selection system with changed parameters, and the Darwinian cycle starts all over again. In the first step of extension, we extend Darwinian terms. Instead of genetic information, we consider general information, for example, content of consciousness, cultural behavior, or constitutional laws. Instead of phenotypes, we consider forms. For example, agriculture or livestock breeding, or for example, democracy or dictatorship. Instead of mutation mechanisms for genetic information, we consider variation mechanisms for general information. For example, imitation, learning, teaching, logical reasoning. Instead of simple selection systems, we consider general evolution systems. For example, the prisoner's dilemma, or for example, the evolutionary systems resulting from the different cooperation mechanisms. This results in the Darwinian cycle for the extended terms, here marked in green. Selection system is replaced by evolution system, genetic information by general information, and mutation mechanism by variation mechanism. And the term phenotype is replaced by the term form. If the Darwinian cycle has been run through many times, a qualitative leap in biological traits can occur. The general theory in the second step, marked red here, assumes that the evolutionary leaps fundamental to evolution lead to the appearance of new information technologies. First, for each new type of information, a storage technology emerges, resulting in a qualitatively new evolutionary system. Subsequently, the Darwinian cycle is run again until there is another leap, which results in a new duplication technology. After further runs, a new processing technology, and finally a new type of information occurs, and the process of the emergence of new technologies starts all over again. In a third essential step of extension, here marked in purple, one can show that each new information technology leads to a new variation mechanism, in particular to targeted variation mechanisms. The higher the information technology is developed, the more the new variation mechanisms are targeted. Examples of targeted variation mechanisms are imitation, learning, teaching, logical reasoning, utility optimization, investment, or genetic manipulation. Targeted variation mechanisms do not change information in a completely random way, but change information with information that has already proven to be advantageous in a previous evolutionary system. To some extent, they shorten evolutionary detours and avoid aberrations. Targeted variation mechanisms are therefore a major reason why evolution is progressing faster and faster. Before we explain the evolution of the evolutionary systems and the targeted variation mechanisms, we show that the GAT leads to a natural chronology of evolution based on the emerging new information technologies. Overall, the entire evolution from the origin of life to the present day can be naturally divided into 8 ages, according to the 8 information types that emerge. These ages correspond to the following information types or storage technologies: crystal, RNA, DNA, nervous system, cerebrum, external local storage, the cloud as external dislocated networked storage, and for the future we can expect a type of information that will be enabled by the coming human-machine symbiosis. Each of these ages can generally be divided into 3 sub-ages according to the new biological technological traits, each of which forms the basis for a new storage, duplication, or processing technology. We start with the resulting natural chronology of the evolution of the living being forms, according to the new traits, respectively to the new information technologies. Let us first zoom in to the age 2, characterized by the information type of DNA, which started about 3.7 billion years ago and lasted until the invention of the nervous system as a new type of information about 630 million years ago. The biological trait of the genetic code makes a storage technology possible which can store the information of how a phenotype is to be built. This corresponds to the age of the single-celled organisms. The biological trait of cell division and cell association, which evolved about 2.1 billion years ago, is a duplication technology for phenotypes. This corresponds to the age of simple multicellular organisms. The biological trait of sexual reproduction about 1 billion years ago equals a processing technology which forms a new information out of the genetic information of the male and female. This corresponds to the age of higher multicellular organisms. Let us now zoom in to the age 3, characterized by the electrochemical information which can be stored, duplicated and processed within the nervous system, which started about 630 million years ago and lasted until the invention of the cerebrum as a new type of information about 6 million years ago. The biological trait of nerve cells and what is called the monosynaptic reflex arc evolved 630 million years ago. These biological traits make it possible for information about the environment to be perceived and stored. The organisms can respond to this information in a simple, immediate reaction, which is called monosynaptic reflex arc. This corresponds to the age of the predatory animals. The biological trait of the brainstem and what is called the polysynaptic reflex arc evolved 550 million years ago. The brainstem stores and duplicates the information to enable the polysynaptic reflex arc to trigger an immediate response in several different organs of the organism. This corresponds to the age of the Apterygota, insects, fish, amphibians, reptiles, early birds and early mammals. The biological trait of the limbic system evolved about 666 million years ago and enabled a processing technology. The limbic system receives information from various sensors and processes it into information that leads primarily to complex emotions, which corresponds to the age of higher birds and higher mammals. Further on, let us zoom into the age 4, characterized by the information type complex consciousness contents in the cerebrum, which started about 6 million years ago and lasted until the invention of writing as a new type of information about 5,000 years ago. The biological trait of high quality associative neural network in the cerebrum makes a storage technology possible which can store simple causal relationships. This corresponds to the age of the hominins, that is, the human-like. The biological trait of simple language, which evolved about 900,000 years ago, is an efficient duplication technology for individual experience. This corresponds to the age of Homo. The biological traits that led to the cognitive revolution about 60,000 years ago enable, for example, logical reasoning as a processing technology of consciousness contents, and this corresponds to the age of Homo sapiens. Further on, let us zoom in to the age 5, characterized by the information type of external logical digital data, which started with the biological trait of writing about 5,000 years ago and lasted until the invention of the cloud, which enables the storage and processing of external networked, dislocated digital data about 10 years ago. The biological technological trait of writing makes a storage technology possible which can store digital data in an external device. This corresponds to the age of the market economy. The biological technological trait of letterpress, which evolved about 500 years ago, is an efficient duplication technology for external digital data. This corresponds to the age of the capitalist market economy. The biological technological trait of EDP, electronic data processing, evolved about 50 years ago. This corresponds to the age of the global capitalist market economy. Further on, let us zoom in to the age 6, characterized by the information type of external networked delocalized digital data, which started with the biological technological trait of an efficient, widely used internet about 10 years ago and will last until the invention of quantum computers in the near future. In the sub-age 6.1, the biological technological trait of the internet makes a storage technology possible which eliminates the need for a duplication technology, because in principle everyone has access to the information which is stored in the internet. This corresponds to the age of the internet market economy. The biological technological trait of artificial intelligence 1.0 and virtual reality is evolving just now in the age of the present, 6.2. Artificial intelligence 1.0 produces new information by a statistical processing of big data stored in the internet. Virtual reality is created by processing information about reality with information from the internet. This corresponds to the age of the AI-based economy. The age 7 lies in the future and is characterized by the biological technological trait of quantum computers. This trait will enable storage, duplication and processing in a single technology. Artificial intelligence 2.0 produces new information not by a statistical processing but by logical processing of big data in the internet. AI 2.0 will be incredibly more efficient in producing evolutionarily successful information than anything we can currently imagine. Let's still have a quick zoom into the ages 0 and 1. In the age 0, the age of inanimate matter, information was generated and stored by self-organization of inorganic matter in the form of crystallization due to decreasing temperatures. No duplication or processing technologies were possible. Age 1 is the age of RNA. Further decreasing temperatures in the sub-age 1.1 and the existence of crystals enabled the biological engineering property of self-assembly of organic matter at crystal surface in form of RNA strand. This led to the creation and storage of information as in age 0. No duplication or processing technologies were possible. This was the age of RNA molecules. In the sub-age 1.2, the biological technological trait of autocatalysis enabled the duplication of RNA. This was the age of ribocytes. No processing technologies were possible in age 1. Now we describe the natural chronology of the evolution of evolutionary systems resulting from the GET and in particular of cooperative systems as a function of the new traits or the new information technologies. Evolutionary systems are differential equation systems that describe the time dependence of the frequencies of forms or organisms. They are generally more complex than simple selection systems, which describe frequencies based only on selection mechanisms. Overcoming prisoner's dilemma is a very important achievement of evolution. Mechanisms that make it possible to overcome prisoner's dilemma are called cooperative mechanisms. Evolutionary systems that are characterized by special cooperation mechanisms are called cooperation systems. We do not go into the details of the individual evolutionary systems here, but only describe in which order and at which sub-age the first appeared. From the age 0 until the sub-age 2.3 we get crystallization, creation, respectively destruction of RNA molecules, genotype selection, that is the survival of the fittest genotype, phenotype selection, that is survival of the fittest phenotype, network win-win systems, and associated with sexual reproduction in the sub-age 2.3, there are a variety of very complex dynamics. Prisoner's dilemma situations first appeared in the sub-age 3.1, as did predator-prey systems and network cooperation systems. Subsequently, from sub-age 3.2 until 4.3, developed the following systems: group cooperation, direct cooperation, dead cooperation, indirect cooperation and barter, and in the sub-age 4.3, the sub-age of Homo sapiens, the norms cooperation and the division of labor. Subsequently, from sub-age 5.1 until the future age 7, developed the following systems: cooperation based on religious norm systems and regional trade, cooperation based on national systems of norms, and national trade, cooperation based on international norm systems, world trade and globalization, cooperation based on global sanctions, global cooperation based on automatic global sanctions, and in the future, the age 7, the age when human society is likely to transition into a cyborg, cooperation will be based on man-machine symbiosis. We are going to see a completely new organization of society with qualitatively quite different evolutionary systems. Now we proceed to describe the resulting natural chronology of the evolution of targeted variation mechanisms, according to the new traits, respectively to the new information technologies. As said before, targeted variation mechanisms do not change information in a completely random way, but change information with information that in some sense has already proven to be advantageous in a previous evolutionary system. To some extent, they shorten evolutionary detours and avoid aberration. The first epigenetic variations possibly occurred in the subage 1.2 of ribocytes, but probably certainly with the appearance of DNA in the subage 2.1, the subage of single-celled organisms. Epigenetic variations can be considered as the first precursors of true targeted variations. Horizontal gene transfer probably first appeared in the subage 2.2, the subage of simple multicellular organisms, when the mechanism of cell adhesion first appeared. In horizontal gene transfer, a cell supplements its genetic information at a random time with a randomly selected genetic information that has already been shown to be evolutionarily beneficial in another cell. When this mechanism had evolved evolutionarily to the point where prolonged attachment was no longer necessary, it became possible for unicellular organisms as well. Sexual reproduction first appeared in the subage 2.3, the subage of higher multicellular organisms. In sexual reproduction, the genetic information of the female cell and the male cell is randomly mixed, but not at a random time, but each time a daughter cell is formed. In this process, the new genetic information of the daughter cell is created from genetic information that has already been evolutionarily proven. Sexual reproduction thus has three major advantages over a purely random change of a DNA base. First, the exchange of whole chromosomes, that is very large DNA segments, leads to a much more extensive change than the mere change of a DNA base. Second, the daughter cell is nevertheless more likely to carry evolutionarily advantageous genetic information. Third, this massively increases the speed of evolution. The creation of swarms first appeared in the subage 3.1, the subage of predatory animals. Swarming can be considered as a monosynaptic reflex of an animal to the movement of animals in the neighborhood, which immediately changes the animal's behavior. Learning of statistical relationships first appeared in the subage 3.2, the subage of Apterygota, insects, fish, amphibians, reptiles, early birds, and early mammals. Learning statistical relationships means learning and memorizing. If event A occurs often, then event B usually occurs. As a targeted variation mechanism, it differs from sexual reproduction primarily in that it does not alter genetic information, but rather behavioral information stored in the brainstem. Imitation of the behavior of other individuals first appeared in the subage 3.3, the subage of higher birds and higher mammals. Imitation in the strict sense differs from swarming in that it is not statistical but individual behavior that is imitated, not only immediately but also at any later time. As in learning, it is not the genetic information that is altered in imitation. However, it is the behavioral information that is stored in the cerebellum or limbic system. As with all targeted variation mechanisms, however, it is primarily evolutionarily successful information that is passed on through imitation. Learning of causal relationships first appeared in the subage 4.1, the subage of hominins. Learning causal relationships means much more than learning statistical relationships related to the subage 3.2. For example, to understand a causal relationship, one must be able to distinguish first between A and B follows C, and from A or B follows C. Second, to recognize that there is a difference between from A always follows C and from A often follows C. And third, that logical consequences can occur not only immediately but also at a later point in time. Learning in this context means that individual experiences are stored as causal relationships in the cerebrum. Teaching first appeared in the subage 4.2, the subage of Homo. The difference between learning and teaching is this. In learning, you process and store experiences that you have more or less at random. In teaching, you do not learn from random experiences, but another individuum imparts targeted experiences. Obviously, evolutionarily, success information is rapidly multiplied by teaching. Logical reasoning first appeared in the subage 4.3, the subage of Homo sapiens. Logical thinking means, for example, that from the logical relations if A then B and if B then C, the logical relation if A then C can be derived. So, from the processing of logical information, a new logical information is generated. A logical relationship obviously is an evolutionary advantageous information. The creation of new logical relations by processing existing logical relations is obviously even much more evolutionarily beneficial than the mere knowledge of some logical relations. Individual utility optimization is another targeted variation mechanism, which first appeared in the subage 4.3, the subage of Homo sapiens. Individual utility optimization is a mechanism in the cerebrum that evaluates possible behavior and realizes highly valued behavior. Obviously, through selection, such mechanisms have developed that has led to an evolutionary advantage. Obviously, animal and plant breeding is a targeted variation mechanism. It developed in the late sub-age of Homo sapiens. Economic utility is measured in money. The mechanisms of economic utility optimization therefore obviously presupposes the existence of money. In most cases, an economic utility correlates positively with an evolutionary advantage. It therefore first developed in the sub-age 5.1, the sub-age of the market economy, when money first became available as a quantitative unit of measure. Investment in real capital first appeared in the sub-age 5.2, the sub-age of the capitalist market economy. It can be seen as a targeted variation mechanism in the following sense. It changes the information about the production mechanism of goods, not randomly, but in a targeted way for the multiplication of goods. In most cases, an investment in real capital and thus in the multiplication of goods is correlated with an evolutionary advantage. However, this is not always the case. Just as individual utility optimization does not lead to an optimum for all in every case, as we learned from the prisoner's dilemma, the multiplication of goods does not lead to an optimum for all, as we know from environmental and climate problems. Nevertheless, both have prevailed evolutionarily through selection mechanisms because they correlate positively with an evolutionary advantage. Investment in human capital first appeared in the sub-age 5.2, the sub-age of the capitalist market economy. It can be seen as a targeted variation mechanism in the following sense. It changes the information about the knowledge of effective production mechanisms of new goods, not randomly, but quantitatively and qualitatively through investment in education, research and development. Investment in digital capital first appeared in the sub-age 6.1, the sub-age of the internet market economy. An investment in digital capital can be seen as a targeted variation mechanism in the following sense. It changes information about the quantity and quality of data storage and processing, which in most cases correlates with an evolutionary advantage. Gene manipulation is obviously a targeted variation mechanism. Driven by artificial intelligence, it is just beginning to gain enormous importance for the whole of society in the present, the sub-age 6.2, the sub-age of artificial intelligence. Overall, utility maximization is a mechanism that overcomes the weakness of individual utility optimization, especially in prisoner's dilemma situations. It will probably only become possible in age 7, the age of the future, because it requires technology for measuring, storing and processing data that is unimaginably powerful today. Maybe this can be fulfilled by quantum computing technology. It will lead to an entirely new form of human society that perhaps could be called a cyborg. Idealistically conceived, the target of Marxist economic theory was precisely the maximization of overall utility for society as a whole. However, this target was in no way achievable at the time because the information technologies necessary to achieve it were lacking. The possibility that individuals can enter into that relationships also plays a particularly important role in evolution. We therefore proceed to describe the natural chronology of the evolution of that relationships arising from the GET. A key feature of that relationships is that they persist over time and therefore must be documented in some form. The nature of the documentation of that relationships depends on the biological, technological traits, respectively the new information technologies of the particular sub-age. That and its documentation facilitate evolutionary enforcement of mechanisms in which service and consideration are provided at different times. That thus facilitates the evolutionary enforcement of win-win systems in particular. Since win-win systems provide an evolutionary advantage for all parties involved, the emergence of win-win systems is of particularly high evolutionary advantage for the system as a whole. The possibility of the creation of that relations and thus the emergence of win-win systems is therefore of very great importance for evolution. Before the sub-age 4.1 of the hominins, no real debt relations between individuals were possible. Only the possibility to store causal relations made it possible for the first time for hominins in the sub-age to enter into two-sided debt relationships. That is, I helped you, therefore you helped, therefore you owe me to help. Social debt first developed in the sub-age 4.2, the sub-age of Homo. The precondition for social debt was the existence of at least a simple language. The possibility to incur a social debt especially facilitates the enforcement of indirect cooperation. Put simply, indirect cooperation means I help you so that someone else will help me. Social debt is documented by the reputation of individuals and typically measured only qualitatively and not quantitatively. An individual's reputation is high if he or she has often helped others and this behavior has been communicated within the group. He has helped us again and again, therefore we owe him help. For this very communication, at least simple language is the precondition. Commodity debts first developed in the sub-age 4.3, the sub-age of Homo sapiens. Commodity debts are debts that are quantitatively measured and documented in commodities such as wheat or animals. The precondition for this was the ability to count and especially to calculate, which only developed with the ability of logical thinking. The invention of money was a very significant advance in the documentation of debts. The characteristic of money in this context is that it provides a uniform scale for measuring and documenting debts of all kinds. The various forms of money have evolved in time with the respective technology traits of the various sub-ages. The more highly developed the technology, the more efficient the form of money and the easier it was for debt relationships and thus win-win mechanisms to develop. The development of ever more efficient ways to document debt is therefore the deeper cause of humans gaining an ever higher evolutionary advantage and thus dominating the entire world today. The development of writing in the sub-age 5.1, the age of the market economy, led to coin money. The development of printing in the sub-age 5.2, the age of the capitalist market economy, led to paper money. The development of electronic data processing in the sub-age 5.3, the age of the global capitalist market economy, led to fiat money. The development of the internet in the sub-age 6.1, the age of the internet market economy, led to electronic money. In the present, the sub-age 6.2, the technology of blockchain money is beginning to gain widespread acceptance. In the future, however, when overall utility maximization mechanisms are possible with quantum computers, that creation will become less important. Win-win mechanisms and cooperation could then emerge through overall utility maximization and through direct human-machine symbiosis. The dynamics of all physical and chemical processes in nature is determined by so-called driving forces. All these forces are determined by the change of the free enthalpy. The change in free enthalpy is equal to the change of enthalpy minus temperature times the change in the entropy, which is called the Gibbs-Helmholtz equation. For example, for the motion of a ball in a bowl, the free enthalpy is given by the height of the bowl wall, and no entropic forces exist. The dynamics of the ball is determined by the slope of the wall, which is exactly equal to the gradient. Interestingly, the driving forces that have occurred over time can also be placed in time course of evolution and understood with the help of the GET. We therefore proceed with a description of the natural chronology of the evolution of the driving forces resulting from the GET. In the age 0, the age of inanimate matter, the temperature has decreased. Therefore, the entropic forces have lost importance compared to the forces arising from enthalpy. This led to the transition of the inorganic Earth surface from the liquid to the solid, and thus enthalpy-poorer crystalline state. In the age 1, the age of RNA molecules, the temperature dropped even further. Therefore, the creation of longer chain RNA molecules was also possible along the gradient of enthalpy. This was probably facilitated by the fact that the activation energy for the creation of the RNA molecules was lowered by the already existing crystal structure on the surface of inorganic matter. In the age 2, the age of DNA molecules, the behavior of living beings is determined by the dynamics of DNA and the corresponding proteins. These dynamics are mainly determined by concentration gradients. These concentration gradients must always be built up or maintained by the supply of energy from outside. Without the constant supply of energy, life is therefore not possible. In the age 3, the age of nerve cells, electric charges became important for life. Thus, since then, dynamics is no longer determined only by concentration gradients, but by the gradient of the electrochemical potential, which must also be built up or maintained by the supply of energy from outside. The age 4 is the age of the cerebrum. The cerebrum is characterized by two features. It is a network and requires much more energy than other organs. The reason why so much energy is needed is that the dynamics in the cerebrum is very far from an equilibrium state, unlike the age 2 and 3, where the dynamics is always relatively close to the equilibrium point. It is precisely because the dynamics are very far from equilibrium that nonlinear dynamics are enabled in the cerebrum, which are obviously particularly important for cerebrum function. Roughly speaking, the dynamics of the cerebrum is determined by the gradient of a networked electrochemical potential very far away from equilibrium. In the age 5, the age of the market economy, individual agents act to optimize their economic utility, which is measured in money. They do this by exerting economic forces precisely in the direction that increases economic utility most rapidly. This is precisely the direction indicated by the gradient of utility. Since different agents do not have the same interests, they exert economic forces in different directions. The economics then moves in the direction of the resultant of these forces. This concept for describing dynamic processes in economics is called general constraint dynamic models and was developed by me together with others. Roughly speaking, the dynamics of the market economy is determined by the resultant of utility gradients. For more details, see a recent book by me and others titled General Constraint Dynamic Models in Economics, published in Emerson 2023, and a corresponding paper. As we know from the prisoner's dilemma, the approach of all agents trying to maximize their own utility often leads to the worst possible outcome for all. There are two approaches to preventing this undesirable economic outcome, often referred to as market failure. These have evolved over the following ages. In age 6, the age of the internet market economy, attempts are made to overcome the weakness of individual utility optimization by imposing additional constraints. These constraints arise in particular from international standards that must be fulfilled. Roughly speaking, the dynamics of the internet market economy are determined by the resultant of individual utility gradients constrained by international norms. In the age 7, the age of the humanity as a cyborg, the weakness of individual utility optimization is overcome by the maximization along the gradient of an overall utility. Now we come to a first summary. From the perspective of the general theory of evolution, the following megatrends of evolution arise. First, evolution produces more and more efficient cooperation and win-win mechanisms. Second, at the beginning of evolution, random variations have determined the development of evolution. However, as evolution has progressed, targeted variation mechanisms have become increasingly important. Targeted variation mechanisms are a major reason why evolution is developing faster and faster. Third, values and norms are a result of evolution. Fourth, the interplay between individual utility optimization, that is competition, and general utility maximization, that is cooperation, is of fundamental importance for the understanding of evolution. Fifth, the course of evolution is characterized by the regular succession of new information types with the respective new storage technologies, duplication technologies, and processing technologies. Sixth, we hypothesize that the evolution also on other planets basically follows the sequence of information technologies shown in the GET. Now let's have a more detailed discussion of scenarios for the future. First, we discuss scenarios for the near future. Since exponential growth is not permanently possible and we are therefore approaching a singular point in evolution, a serious change in the quality of evolution will occur in the near future, whereby 4 different scenarios are conceivable. Regardless of which of the 4 scenarios will occur in the near future, in the long run, the scenario of the entire human race as a single individual in the sense of mankind as a cyborg will result, which we will discuss on the next slide. The quality of the 4 scenarios for the near future will essentially depend on 2 factors. First, does the technical infrastructure based on the division of labor collapse due to wars or other catastrophes, or can it be maintained? Second, is the prevailing value system characterized by the social Darwinist law of the strongest, or by a cooperative, humanistic basic attitude? According to this, there are 4 basic types for a possible future. First, the apocalypse, a collapse of the real and financial infrastructure and the social Darwinist struggle of all against all leads to the apocalypse, comparable to the times of the migration of peoples and the recurring wars. My subjective probability of occurrence of this is 10%. Second, the relapse into small-scale structures. If society is characterized by a cooperative humanistic value system, but the infrastructure collapses, for example, due to a severe environmental disaster, society will return to a subsistence economy with small protective communities in which everyone helps everyone else. My subjective probability of the occurrence of this is 20%. Third, the fascists take over by the government or by international social media groups. Large-scale destruction of the infrastructure, as in the two previous scenarios, is rather unlikely. However, it is to be feared that society will continue to be characterized by a social Darwinist value system for a long time. The most likely scenario is therefore a fascist takeover by governments or by international social media corporations. The current and future technical possibilities for monitoring people and influencing or perhaps even determining their opinions are so enormous that they will definitely be used by the powerful in the future. Just in the past, it was religion that the powerful used to enforce their interests. In the future, it will be the unpredictable developments in surveillance and manipulation techniques. China's efforts in this direction have become known in recent years, but it is also to be feared that Google, Microsoft or Facebook or other new corporations will develop in this direction in the future. My subjective probability of the occurrence of this is 40%. This scenario could also be the starting point for the scenario we expect in the distant future, mankind as cyborg. Fourth, sustainable prosperity for all in a humanistic and solidary society. Even if it appears to some, perhaps even to many today, as an idealistic, unrealizable pipe dream that future generations will live in a society characterized by solidarity, cooperation, peace, humanism and common goods. It is enough to take a look at the past of human society to see that profound positive changes in human society have very much occurred over time, albeit very often only after very painful experiences. Consider, for example, the introduction of democracy or the welfare state. Although mankind will probably still be confronted with foreseeable and unforeseeable crises, I am still a little optimistic. My subjective probability for this optimistic scenario is 30%. Finally, we discuss a likely scenario for the distant future. Our analysis of evolution so far shows, even though there have been repeated catastrophic events in the course of evolution that have led to the mass extinction of species for a wide variety of reasons, in the long term, evolution has developed into an ever greater diversity of species with ever more complex individuals. Therefore, it can be assumed that evolution will continue in this form in the future, at least in the long term. In terms of evolutionary information theory, the following scenarios is conceivable. Over many epochs, technological evolution has always occurred in the sequence of new storage technology, new duplication technology, and new processing technology. Only in the last epoch, with the internet, has an information technology developed that combines storage technology and duplication technology in a single technology. We therefore hypothesize that the next era, whenever it comes, will be characterized by a type of information and an information technology that combines storage technology, duplication technology, and processing technology in a single technology. We assume that this technology will be characterized by direct human-machine communication and will lead to a merging of the real and virtual worlds. The technical precondition for this could possibly be created by quantum computers. This will lead to a network of people and the environment that corresponds to the network of the individual cells of a present-day individual. Just as the cells of an individual have no significance on their own and are not capable of survival because they are all interdependent, the individual human beings will also lose their significance and will not be capable of survival on their own. In a word, humanity as a whole will have to be considered as a single life unit. It will then consist of human individuals, just as the individuals are to be regarded as a single life unit consisting of cells. Clearly, this will have serious implications for the behavior of the individuals, for relationships between people, and for the whole of human society, culture, and economy. Just as evolution has driven cells to generally behave in a way that leads their behavior to maximize utility, for example, evolutionary fitness, for the whole individual, so too humanity will be driven primarily by maximizing overall utility. However, this will then no longer be done through norms and sanctions, but through a completely new way of organizing society. However, this scenario does not necessarily have to arise in this form for the future. For if cells do not behave in the sense of overall utility maximization, but in the sense of individual utility optimization, then they will multiply without consideration of entire individual. That is, they will behave exactly like cancer cells. Just as the development of cancer cannot be ruled out in the course of evolution, the behavior of individuals in mankind determined by individual utility optimization cannot be ruled out. Just as cancer usually leads to the death of the individual, behavior of individuals determined by individual utility optimization can also lead to the extinction of mankind as a whole due to the far-reaching interconnectedness and interdependence. In closing, we would like to point out some further new ideas of the general theory. There are, for example, the link between the evolutionary information theory and the general theory of evolution, constraints as essential elements of evolution, the illusion of free will as an evolutionarily successful trait, the difference between individual utility optimization and overall utility maximization, and the path from artificial intelligence 1.0 to artificial intelligence 2.0. Now I would like to come to my summary conclusion. Looking at the evolution from the perspective of information types and information technologies, the entire evolution from the origin of life to the market economy, and maybe in the future, can be better understood in a natural way. More information can be found in a just published book on my homepage and in YouTube videos. If you have any questions, please do not hesitate to email me. I am happy to answer all your questions by email. Thank you for your attention.